Match Fishtank, Unit 8, Lesson 10, Anchor Problems. In this anchor problem, we're going to help Robert decide whether New York City or San Francisco has better weather when he's considering whether to move there. Now, of course, this is only one of the factors that anybody would consider when moving to a new city, but weather is pretty important to our lives. We're first asked to find the mean, the median, the range, and the interquartile range for each city. So we're looking at two measures of center, mean and median, and two measures of variability or spread, range and interquartile range. Here are my calculations for New York City. I started by putting all of the data in order from least to greatest, and then I used that to do the remaining items. So I found the mean by adding up all of the data points and dividing by 12 because there's 12 months in a year, and found that the mean was 63 degrees. The median is halfway between 61 and 65, the sixth and seventh data points, and that's 63 degrees also. The range here is from 39 all the way up to 85. That's a pretty big range of 46 degrees. And even when you only consider the interquartile range, so the range of the middle half of the data, that's 81 minus 47, or 34 degrees. Now, when we take a look at San Francisco's mean, median, range, and interquartile range, we can see that while San Francisco has a very similar mean, slightly higher, and a very similar median, against very slightly higher, the range is significantly less, and so is the interquartile range. This tells us that although both cities have a center in approximately the same place with regards to temperature, the temperature in New York City is much more variable. It's much more spread out between colds and hots. And the temperature in San Francisco is more clustered right around that mean and median temperature, clustered around the center. So that can help Robert make some decisions. If Robert wants to live in either city, you could argue that they have about the same center temperature based on both the median and the mean. So either city is going to have the same average temperature across the year. But if we wanted to argue that Robert should live just in San Francisco over New York City, then we might consider that the temperature range in New York is much greater. So if Robert would prefer to live in a place that is the same temperature all year long, San Francisco is going to be a much stronger choice. Now, this isn't part of the question, but if Robert wants to live in a place with temperature variation for the seasons, then New York City would be the stronger choice. When you look at both measures of center and measures of variability, you can get a more broad range picture of a data set than if you just look at one or the other. Our next anchor problem talks about Raquel and how she's training for a road race. So we're going to talk through these. If Raquel wants to follow a training plan that's the most consistent, well, it sure looks like training plan 2, it has a range of 1 and an interquartile range in 1. So that means it's not varying very much at all from the median and the mean, maybe between 4 and 5 miles. That's a very consistent training plan. So training plan 2 would be the most consistent. And looking at the range and the interquartile range is what helps us figure that out. If Raquel wants to make sure that she runs 4 or 5 miles per week over the 5-week period, so I know that I want to then look at how much she'd be running, and in all cases, she runs about the same number of miles. I notice here that training plan 3 has a greater median, and it also has a significantly greater range and a greater interquartile range. So I think that that means that training plan number 3 is going to start out with fewer miles and ramp up to a lot more miles. Maybe she'll even spend some weeks where she's not running at all in order to get a range of 10 miles in there. Training plan 1 has the mean and the median pretty close, but she's going to range between 6 miles overall, and the interquartile range is 4.5. So that kind of looks like it's ramping up a bit each week. So training plan 2, again, looks like the only one where she's going to run 4 to 5 miles every single week because the range is so narrow, which means that each week will probably be right around the centers. Will have to be right around the centers. Now, it'd really be nice if we had what's called a 5-point summary or a 5-item summary here for these, and that would include the median, the interquartile range, because it's going to give us the minimum, the lower quartile, the median, the upper quartile, and the maximum. While this data is useful, it would be helpful to have those because then I would know when the little amount is and how much the top amount of miles she could run is. That's something we'll get to in a later lesson. So if Raquel wants to follow a training plan that gradually increases the number of miles, which one should she use and why? I would argue that if she wants something that's gradually going to increase her miles, I think training plan 1 would be the smartest one because it seems like while there is a range, it's not as big here as training plan 3. Training plan 3, in order to get a range of 10, that would imply that at some point during her training plan, she'd have to be running at least 10 miles. So that wouldn't be ramping up gradually, I don't think, because that would mean that at 1 week she wouldn't be running at all. So I believe training plan 1, because it gives a mean and a median that are about the same, and a range and an interquartile range that indicate that there's some variability in how much she's running, would probably be the best if Raquel wants to ramp up slowly. When you're given data sets to analyze, looking at these summary measures of center and variability, you really have to consider what impact that would have on the data set and maybe even make some test cases like I talked through, saying, okay, if the range is 10, that means one end has to be at least 10, and that would only be if 1 week was only 0. Coming up with examples can help you understand those points. Finally, we have a situation where we're considering either center or variability. Our situation is that 7th graders take both a math test and a literacy test. Scores on both tests could be any number between 0 and 100. And so for question 1, they ask us, on average, did students score better on the math test or the literacy test? I believe this is asking us to consider the center of the data sets because they're wanting to know, did the typical student score better on the math test or on the literacy test? And that could best be seen by what the center of the data is. Question 2, were students' scores more consistent, more similar to one another on the math test or the literacy test? This would be one that we should consider variability in. If the students' scores are spread out all over the place from 2 all the way up to 99, that would be not very consistent because there's a lot of variability. It's very spread out. But if the students' scores were all clustered around, say, 75, that would be much more consistent. Measures of both spread and variability measures of both center and variability can help you analyze data sets in real-world situations.